Hello everyone, and welcome to my weekly streaming about the Uno platform. So generally live coding the Uno platform, adding features, looking at the discussions that are happening during the stream for questions and others. So uh, if you're uh, if you're oh, that's an interesting one. If you're having questions, let me know and jump in. So it's all about taking a look at everything that's happening in Uno platform. And this week, something has been we've been releasing a new version of the Uno platform, Uno platform 3.8, adding new features like the new WinUI calendar controls. So two controls, the grid control that we've been importing from the WinUI source code, so the original grid control. This one has been very interesting. Performance improvements, those are quite nice, and new Linux scenario that we've added so that you can do some more embedded stuff if you're on the Linux side. So the first two ones are calendar date picker and calendar views. So those two have been asked a lot, especially for the uh, for the enterprise customer of ours that are developing applications that do need to select dates. That's particularly important. And I'm going to show you a quick walkthrough in the Uno playground that takes a look at this. So if you go to date and time here, you're going to be seeing the new controls that are available. So a while back we added the date picker. So it's a control that allows you to select a date like this, and you scrolling, and then you can select that date and it appears like this. So it's just basically selecting the month, date, and year specifically. But in many cases, you want to see the actual dates being selected. So and seeing the month and days, so it's easier. So the first one is the calendar date picker. So this one is an actual pop-up. So if you select a date, then it shows you the selected date here, and the other one is a calendar view. So the calendar view is the same one as the one that is in the pop-up, but is displayed directly as a control. So it allows you to select dates and not have a pop-up just appear when you're selecting something. So that control is actually pretty complex. It's a control that was also imported from the WinUI code base. This is a control that have been developed for many years. I don't know how much Microsoft has spent developing that control, but there are so many things that are inside related to specifics of localization and automation, and making sure that it is accessible and works in many scenarios. So that is quite interesting. So it even supports using the wheel to select that dates like this. It also supports multiple selection. So for instance, you can change the selection mode here. And if you say multiple, then you can actually select multiple dates that way. So it's a quite interesting control that I'm sure you're gonna have fun working with. So if you find anything that doesn't work properly or anything like that, odd behaviors and others, just let us know by opening issues on the Uno platform repo. Definitely looking forward to those and see how you're using that control. So that's it for dates. Now let's take a look at the rest. So lots of performance improvements that we've been working on, and I spent quite a bit of time doing those kinds of improvements. One that is particularly interesting is the dependency object improvements, and we've been storing the content of dependency properties. So each individual property that you can change. So when you take a look at something like this is a dependency property, and this is not just a variable. A dependency property is something that has a notion of precedences, so you can set multiple values to the same property, and depending on what's the highest, you can set or clear multiple values at different levels. And this is something that's particularly important when you're dealing with, let's say, a content control, and you set the color in a content control. if you have multiple text blocks underneath, the notion of inheritance is particularly important. And in many cases, that inheritance is not actually used, or is just set to the default value. So let's say, for instance, if you take a look at the calendar date picker, that one has a lot of properties, and most of those properties are just initialized to the default value, or just read only once, or just read to that default value, or not even read at all. So that can happen in some cases. And the change that was made, it was to make sure that we're not creating properties and creating arrays inside to manage all those layers and inheritance precedence management for dependency properties. And doing that kind of change kind of gave an interesting boost in reduction in memory consumption. So we're going from 78 megabytes to 61 in a before after for a main page on a very large app. So that's pretty interesting. And same goes for GC handle counts. The garbage collector is tracking everything that happens during the application running, and the more you have handles that are alive, then the longer the GC will take to collect everything. So in that context, that means that dropping from that much is always going to be good for performance. Another one that we've improved is the time spent or the operations that are spent by when creating UI elements, and that one is particularly important when you're creating pretty complex applications that have lots of UI elements. So we've been adding a few things, and one that had a very large improvement is the notion of visual states. And some of the controls that you're creating, that you can create, have very, very large visual states, and that one is actually one of them. List view item, navigation view are pretty large ones. The changes are related to when you're creating control and a template is so that kind of state. So that one is a list view item, and inside of a list view item, you're going to find all the states for that control. So pointer over pressed, selected, pointer over selected, press selected, the disable state, the multi-selection states, and everything like that. So all those lines that you're seeing here are actually creating individual elements one by one. And in most cases, if you're not using multi-selection, those elements are not going to be useful at all. So what we changed is those controls are those elements are not created they're currently created if that visual state is actually needed. So that makes for a quite interesting performance boost when creating applications. This is something that impacts everything, including all platforms, including iOS and Android. And the Uno Playground is one of the interesting ones. When you're doing updates, an application starts actually quite fast now, a lot faster than it used to be. Same goes for the calculator. So once the application has been loaded once, then the application start quite faster when the cache has been populated already. So that's it. So that's the startup. So that's the second startup. I just pressed F5, so it stays in cache and then loads up pretty nicely. So that's the performance improvement that have been done. So take a look and see how that helps, how it helps for your applications. The new grid implementation also, that's a very nice one. That one is we since the beginning of Uno, we had our own implementation of the grid control, which was not exactly the one that Microsoft was using. So it made for smaller discrepancy in terms of implementation, and we've basically ported the control that comes from Microsoft, and they spent quite a bit of time optimizing it, and we're seeing significant improvement in raw grid performance with measure and arrange when doing, let's say, for superposition measure. So if you have only multiple controls stacked on top of each other, that happens quite a bit. It's 2 times faster. So actually 3 this time. So that's another one that's interesting. So it adds up to the whole thing when optimizing this. I see that Alain is here. So yeah, keyboard shortcuts do work as well. So you have well, there's the mouse on top of it, but you can move up and down and see your control moving around. So that's the kind of thing that we're working on. So if you see keyboard shortcuts that are not doing what they should be doing, let us know. It's something that we're on the lookout for. Another one that we added is a Linux frame buffer and lib input support. So those are if you have an embedded device that doesn't have an X server running. So that's the kind of support that is of interest. So if you wanna have support for this, when you create a .NET New template, you're gonna see that there's a project from a .NET New template. You're gonna see that there's a new Skia Linux frame buffer head that allows you to create and run your application without an X server or a Wayland server running. That's something that's pretty useful when running on embedded device with limited capacity. And the rest is what we're going to talk about today. So WebAssembly AOT support. So the debugger support that I talked about a few streams ago. And the Windows AOT support. The Windows AOT support that is going to be allowing for running applications directly without having a WSL installed. So WSL was, it's nice, it's pretty useful, though you have to install it, you have to maintain it. It's a different set of tooling. So that's something that's pretty interesting when running directly there. And a few other things that you can take a look at when looking at the blog post that we added, like the uniform grid layout. So let's take a look quickly at what that means for running the application, running an AOT build on Windows specifically. So what I'm going to do is set up the application running here, and we'll see what we can do with this. So the Bootstrapper, so this is the solution for the Bootstrapper, and what I'm going to do here is just select the AOT application here, and we're going to see what that does. So this is a sample application that's inside of the Bootstrapper. So the Bootstrapper is the package that allows to run the application, to run an application using WebAssembly, and it packages that into an application that you will be able to use inside of a web browser. So this version of the Bootstrapper is able to run on Windows without using WSL. So I'm going to be enabling the build logging so that we can take a look at what's happening. And let's rebuild. So when rebuilding, it just builds a whole suite of things that are needed to run the Bootstrapper, something that you don't need to do when you're running your application directly. But since we're going to be spending a bit of time inside of the Bootstrapper for today, let's take a look directly. So let's see what's happening for now. So I haven't started the Bootstrapper on that machine specifically, so maybe there's something that's missing. So let's take a look. Okay, so it says Python was not found, run without arguments to install from the Microsoft Store, disabled from settings. So we're going to go and install Python. So if you go to Microsoft Store, you can just search for Python. I think you can take pretty much any version of Python. It's Emscripten uses its own version of Python, but to be safe, let's select 3.7 for now. So we're going to be installing that version specifically. So this is something that you're going to have to do if you're running your application. If you're going to be building your application using WebAssembly and the Uno platform. So this is going to be installing soonish. And so the idea is that Emscripten is bootstrapping itself using a version that's installed on your system, and then moves over to its own version of the Python tooling. So one of the things that is important, so it may not work at the first try. You may have to close Visual Studio and start it again because there are environment variables that are set. So we're going to see if that changes something, but it may still not work. So we'll see. Yeah, it does work. Okay, so there's one thing that I need to change. Oh, maybe not. So let's see. I'm probably gonna have to document that one just to make sure. Okay, so it says EMCC is not recognized, so we're probably gonna have to adjust a few things. So we can see here that, so this is still a preview version, so there may be things that don't work for you, so it may be something that we need to adjust somehow. So let's take a look at what happens now. So we have EMCC that is not recognized. So what we're going to do is just close the Visual Studio to make sure that we're not having the issue that I was talking about, and start the Bootstrapper solution again. So let's see if that works better. So the interesting thing about the support for Visual Studio for Unscripted on Windows is that it was added quite a while back, but the .NET team only added support for it quite recently. So because of their work that they're doing on Blazor, and we were able to add support for it recently as a result. So that's always interesting to see. So now I don't know if we're going to pick up that build. Yes, maybe. Let's see if it works better. No, it's still not working. So we're going to troubleshoot what's happening with the Bootstrapper specifically at this point. Okay, so it says Python is not, so EMCC is not available. So for some reason, it's not able to run Python, probably because one of the commands that should be ran at the beginning is not running properly. So we're going to be troubleshooting this one. So there's that. So we can see here that that command is run at the beginning with Ninja. So we can see that Ninja is running, but for some reason, this is not working. So I'm going to try to troubleshoot that one specifically. So if we run this, what does happen? So we're going to be opening a command line and see if there's another issue somewhere. So running this. So if we run EMCC here, does EMCC run? So, okay, so it's not running. So maybe we're missing something. So I know I changed something recently, so maybe it's related somehow. So there was, instead of the 2.1, maybe, no, EMCC is still not available. So let's see. When we run this that way, there should be an EMCC that's available. So it's not available. So maybe it was downloaded incorrectly. So we're going to go and see if in EMSDK here, we do have the EMSDK available. So in here we have scripts, Docker. It looks like that the SDK is not downloaded completely for some reason, because it's supposed to be in that folder. But there's definitely not enough. Okay, so let's drop this for now. And let's try it again. So there's a script that's part of the Bootstrapper itself that allows to download the whole tooling and make sure that it's running properly. So it's run as a mscript setup here. It's an mscript setup script that's here. But for some reason, the download is not working properly. So the CI is working properly. So that means that it's doing the right thing during the CI. But for some reason, it worked on my machine and on the CI, but it's not working on this one. So we're going to try to troubleshoot why that happens. So we can see that it's supposed to be downloading the EM SDK, SDK, supposed to be installing it properly. Oh, now it is. Okay, so I see that. Oh, that's interesting. So that would mean that if Python is not enabled prior to running the first initialization of the mscript and SDK, then the SDK is completely messed up. That's interesting. So that we're going to add a new error message validating that Python's available before installing Emscripten. So we can see now that the build is actually running. It's taking a bit more time. And let's see now that when we're sorting by CPU time, we should be seeing some Windows processes, but for some reason the build is probably done already. This is probably just doing something else. Yeah, the build is definitely doing something else, or downloading. Oh yeah, it was downloading, so that's why. Okay, so now we have the setup, and now we have .NET running, which is good. We have Clang that's running, so that means that the tooling is set up properly, so that's good. So Clang's running. We have a few other things that are running with MonoAOT as well. So everything's running, so there's no need for WSL installed. So if you had WSL installed, it's not needed anymore. Everything's running on Windows. And so the last part is wasm-ld, so it's linking up everything up so that we have a final binary for .NET running. So that part is generally quite long. There are a few ways to make it shorter because LLVM is optimizing quite a few things behind. So that is something that we generally want when running on a directly on a CI server when you're making a release build. But when you're debugging locally, it's not needed. Hi Yosu, thanks for joining. So that's the way. That's the way to build. So that should be good. So we got the wasm up that's done now, and finalizing a few things when running Python again, and we should be done with the execution. So we have our build running. So now if we start the app, we should be having something that runs properly, and it does. So if you take a look at the startup, we can see here .NET 6, interpreter, and AOT, and all this has been built on Windows without anything needed to with regards to WSL or Linux. So that's pretty cool. Okay, so that is something. So we're probably going to be making one change to make sure that we're testing that Python is there. So that is something that was needed before. So in the Bootstrapper, we have the shell task here, and there's a Emscripten validate something. I don't recall. So Emscripten, you got Emscripten Windows run process. There's lots of Emscripten. There's somewhere validate Emscripten. There it is. So we have validate Emscripten, and that one is making sure that when you're on the specific platform, it sets up everything properly. Let's say if you're on Linux, it's determining the home, the current home. It's determining a few other things, and downloading the Emscripten SDK at a proper location. Shared location, because it's I think it's 800 megabytes or something, so you don't want to re-download that. So the problem here that we had is that Emscripten setup here needs to have a Python available, and if it's not, we have to fail gracefully. So what we should be doing is taking a look at the Emscripten setup here, and probably failing somehow if an invocation to Python does fail. So we can do some validation. What we could do is actually go take a look at what they're doing in Emscripten. When you do an EMSDK install or something like that, then actually do have we could probably take the same thing that they're doing to validate that Python's available, but before they're doing it. So we got to construct an environment here. CSH, there's EMSDK about here. So Python's not available, what they can do it here. So they're looking up for Python explicitly like this. I'm not sure if we're going to be doing it that way. So let's see. It would be about, let's say if we invoke Python, let's say we're going to be calling Python tool like this, just to make sure that let's call it Python invalid. If we do something like this, Python invalid, what does it do? Does it fail properly? Or because if it fails properly, that's what we need. Otherwise, we're going to have to do some checking of errors, errors after Python invalid. Okay, so we have the marker here, so it's not what I needed. So let's cancel the build for now. And to cancel the build, we could probably just kill. Let's kill Clang. I think there's Clang running here. Yeah, build cancel. There you go. So we're going to be removing the script and SDK. Maybe not just that one. Well, let's remove everything. And we're going to try that again and see. Oh, it's actually way bigger. It's 1.4 gigabytes. So that's pretty large. So yeah, it's something that you don't want to repeat all over again. So just use that one. Okay, so we're going to go to and try to see if we can see if Python invalid is doing the right thing. Otherwise, we're going to check for the error afterwards. But it's likely not going to give something interesting. So let's see. So I don't know about you, but I never remember in that specific command line. So let's say we're going to do batch fail error, because I never remember how to do that properly. So the batch script, we can do the error level. Yeah, that's going to be fine. So let's take a look about that one. Okay, so that would be Python. So so that one doesn't look like it did something. Let's try to rebuild and see how it fails. Okay, Python invalid is recognized, but it's still continuing. So that's not what we want. So let's stop it ahead of time. We're going to be stopping them as build for now. I think it's probably doing some Git stuff. Is it doing? No, not really. Okay. So we're going to be running Python. And do we do this? Yeah. I'm going to do it that way. And then I'll change that afterwards, but that should be good. So with this, we should be good. The invoking Python should be enough now as is, and the installation should happen properly. So with this, let's do it again. I'm going to be removing, actually, let's rename for now. We're going to have the deletion just happening in the background, so we don't have to wait for that to happen. And let's do it again. So when we're building, we should be seeing that it's going to happen properly. Okay, so maybe we should be doing something like proper version or something like that. Probably it just got into, so we're going to be adding something, just validating dash version or something like that. That should probably be enough. Yeah, that should do. So it's going to be dash version instead. So that should do. And now what we're going to do, we're going to troubleshoot something that happened to be in the other that was reported by someone that was testing the new version of the Bootstrapper, and that version of the Bootstrapper is doing something quite interesting. So you got two ways to debug an application. So let's move to that one, so we don't have to wait for scripting to be downloaded properly. So let's run that one. You're going to go in debug for now. There's no need to go there. So let's build this. So when you're running the application using the debugger, Visual Studio is picking up. So you press F5 and that runs properly. The problem afterwards is that, so you have a message here. So let's see. I don't know if I've set up the launch settings. So you get the launch settings. So here you don't have the parameters that are needed to enable the debugger. So we're going to add that. So we go to the Bootstrapper main page, and there's a line that you can add here. So how to use the Visual Studio Debugger. You can take this and add that next to the launch browser lines on both. Now let's do it again. And now Visual Studio is going to connect to the browser and allows the debugging to happen properly. So now we should be able to put a, well, not that one, it would be that one. Should be able to put a breakpoint inside of the console.writeline if it all worked properly. But it looks like for some reason it didn't start. Maybe it'll take a little bit more time. Let's try it again. So did I change? Oh, I changed the wrong one. I did change the other one. So let's change the other sample. That's why it's not working. Okay, so I changed that launch setting and not the other one. So that was validating the other one. So let's try it again. So now Visual Studio is connecting to it, and I have in the program here, I have a timer that sets off, that is fired off every 5,000 milliseconds. So you can see now that I am in the timer, and it's something that was not working properly before. So you see that there's a this that's available for some reason, probably because it's a self, but there's nothing in it. So you can see that the underscore is actually null, but that's good. So now the interesting thing is that we should be able to start the debugger without running inside of Visual Studio, and something that may be of interest when running there. So when you start the application using Control F5, so without the Visual Studio Debugger, there's a set of commands so that you can run like this. So you get the remote debugging port here that's available. So it's something that can be done. So what we're going to do is we're going to start the browser again, but using that command line. So it's a way to debug the application without having to run inside of Visual Studio. But it seems that there's an exception somewhere. So you can see here that it fails for some reason here, because the debugging proxy is not working properly. So we're going to go and see why that happens. So it would be in the debugging proxy, line 91. Actually, target picker UI. Okay, doesn't want me to select the text for some reason. So we're going to go to that class, line 91. So in there, the problem seems to be that there's a null reference somewhere. on line 93. Okay, so that would be on that one. So could it be that available tabs is null or something like that? That could be something. So to debug this, we can start the application without the debugger. So removing the debugger from here. And so we're going to comment out that line so that Visual Studio doesn't try to load anything up from its own debugger. And then we're going to put a breakpoint there and to see what happens. So if we do this, that's the interesting part. So when we press F5, you're actually debugging. When you're inside of the Uno tooling, you can debug the web server that hosts the application that is served from this. So if you're running from, let's say, so we're inside that browser. So if we do this and then we launch the debugger, we should be hitting the breakpoint at that location. So we have tabs. And yeah, it looks like everything's null. So that could be a problem. So it's something that it's a piece of code that comes from Blazor because it's hooking into the whole debugger ecosystem that is connected to Visual Studio. So it may be that feature is not available anymore. I have not looked at Blazor recently, specifically running debugging an application. So probably because it works inside of Visual Studio, they disable the feature for debugging the rest. So it could be that that get string async is not returning what is supposed to be returning. It was supposed to be returned previously. So we're going to try to see if we do that again, what happens when this is returned. So we have DevTools description, ID type URL. So that looks good. Browser tab. So it looks like the content is okay. Let's put that somewhere in there. So browser tab is a class and it has not the same thing, but it has DevTool front-end URL, ID, title, WebSocket URL debugger. So it may be because those are fields and not types and not properties. So let's change this and see if that helps. So the reason for this, the reason this is written that way is because in the .NET runtime, this is a record. And the Bootstrapper is still not built with C#9 yet. The .NET team has moved all over to .NET 6, but we still need to run on .NET 5, so can't take a dependency on .NET 6 yet. So had to remove the records and move them to something else for now, at least. But maybe soonish we're going to be changing this and move to C#9 for the Bootstrapper itself. Okay, so the CI has been built. And we're starting it again. So now we have to go to the other browser and refresh this. Launch the debugger again with Alt, Shift, and D and see if we have the right deserialized response now. Yes, we do. Okay, so we have the dev front-end URL, the ID, title, type, and the WebSocket debugger URL that is actually needed for the whole thing to taking the fun out of what? Hey Dan, taking the fun out of what? Is it about .NET 6 or is it about the debugging the debugger stuff? So so this is working properly. So let's see now if we continue. Get a matching tab, which is the right one. And let's see if the debugger is starting properly. So in general, in the sources folder, yes, it works. So that scenario still works. That's pretty good. So we can see that the DLLs have been loaded up and you can even see a few things. So this one for some reason is not available. This is supposed to be. Yeah, no worries. No worries. Yeah, so net 5 instead of net 6. Yeah, I mean, yeah, net 6 is going to happen soonish. I mean, there's part of the Bootstrapper that are running on .NET 6. It's actually something that's, if I remember correctly, completely needed. I think the dev server is actually running is actually having a net 6 variant of it, or maybe not that one. I don't recall which one that is. Not that one. So no, it uses net 5 for now. So we're going to move to net 6 at some point, but not fully there yet. So that one is supposed to be happening and providing the files and the content of the files using source link, but for some reason it's not providing the files. So let's see if there's another one that should happen. So let's see, maybe those are not having it either. So there's file here. So that one works. So it works because it's the application itself. There's even that one that's working. So that's pretty cool. So if I put a breakpoint, does it stop? Yes, it does. Okay, so I broke at the there's a breakpoint at the right location and it works properly. So this is still working. So this is a scenario that that is still supported by the .NET team. So you don't need to have an actual debugger in Visual Studio running. So that's pretty nice. Okay, so that's another thing in the box. So now we're going to take a look at something. So because the .NET team has been looking at some interesting issues, and there's actually one. I don't know if you can see it there. We could probably see it using the profiler. So we're going to take a look at one of the issues that I had. I actually had opened an issue on Uno. So let's go to the Uno repo. We're tracking all the .NET issues that we're opening on the .NET repo, and there's one in particular that's related to performance specifically, and it's the try finally performance. So one of the problem that happens when running with Mono AOT is that try catch in general needs to go through .NET to JavaScript first, because WebAssembly doesn't have at the low level doesn't have a way to catch exceptions. So one of the things that happens when you do this is that actually you probably could see that one in the AOT build that I had there. If I didn't close it completely from the previous build that I had, I think it was in release. Yeah, the dist is still here. Okay, so if we open the file, that one is the right one. Yes, there it is. So it's the gigantic file that Emscripten is generating for many things, but there are some parts where we can see that .NET is generating small functions that are just there to catch exceptions, pretty much. So I don't know if we can find one. So I'm going to put it a bit more. Let's see if we can find one. Throw. Let's see, throw. Or maybe CPP throw. I think there was a CPP throw. Or maybe not. Maybe not in this one. So you get many throws, invokes. No, that's not a type of property. It's not there yet. Yeah, I'm not finding it. So yeah, anyways, so you can trust me there. The idea is that the runtime is wrapping functions around a try catches so that it can intercept the function calls. So if you're having a try catch, so actually let's open. I have a sample project that shows this issue specifically, and we're gonna try to see if that improves directly there. So it's not Uno samples, it's something else. I don't recall the name specifically. No, not code space. let's go find the title for this one. It's actually on my name. It's called Wasm Samples. Oop. And I'm storing all this there. So many issues that we're opening here. And that one is the one that was open there. If I go back to Uno, it's the issue that's called 5783. And I should be having it somewhere here. So if it's not there, probably have another one. So if it's not there, we're going to create a new one. Okay, so let's clone that one. And we're going to try to see if the performance actually improves in between new versions of the .NET Runtime. So I made a newer version of the .NET Runtime that contains one specific fix that was done by Zoltan Varga, that tries to, let's say, unwrap try-finallys that don't have a catch. And that pattern is happening quite often. I thought I had it, but it doesn't look like I do. So let's see. If I have that one, so that one's a wasm shared, not that one. I had some with performance. Well, that one's pretty close. You can probably do that one. That should do. So okay, so let's open that one. It's close, but so that one was a test that was done to validate performance with nullables, and nullable performance is a problem. Okay, so let's remove this. So we're testing a few things. So what we want to do is see the performance for enumeration of a list of T. So what we're going to do is just actually going to test a few scenarios, because Zoltan said that he fixed only the list view of T, the list view T. I'm doing too much Uno, so now list the list view now. So is improving list of T and not other types for which the finally content is not available. So just so you know, actually it's probably easier to actually do that thing. So we're gonna, well, let's do it first. So let's test a list of T first, and we're gonna see what happens then. So list of T, and we're gonna create one list of T here. Let's do a list of objects for now, because list of value types may behave differently, so we're going to be doing this for now. And the scenario that we want to try out is to enumerate using a for each, because that's where there's a try finally that happens to be added that takes some time when debugging, when running the application. So we're going to be adding many elements there. So I could use ranges here, but I'm not sure if it's available in that version. So I'm just going to be using standard enumerable, and it's going to be, I'm just going to add nulls because it's not particularly important, the value here. We're just enumerating values there. No, not select. Oh, no, okay, so it doesn't want me to add. What did I do? Range.select, it says because it doesn't have the right type. Okay, so it's type. So now I'm going to just enumerate the values there. So we probably should be doing this using benchmark.net, but let's start with a simple one. So sut.count. Oh, it's for each that I need, not a for. And we're going to be looking at all the items that are in SUT, and just do a counter. That's it. So that the actual for each just happens to do the right thing. So when we build this, we're going to take a look at the IL of this, because that's where the performance issue does happen. So is it building using? Yeah, it's building using AOT for now. We can probably take a look just at the assembly in the meantime. So we're in debug, and let's take a look at the DLL that's been generated. I think I have a file spy available. There it is. Let's take this out, and let's take a look at what the code, what the generated code is for the test list of T. So when you take a look at this, it's not particularly interesting. Now, if you take a look at the IL plus C#, now that becomes a bit more interesting. So what you can see here is that when you do a for each like this, there's an implicit try and finally block that's added automatically. And the reason for this is that when you're doing for each list, there's a get enumerator that's done here. So you get it, the get enumerator is done here, and the contract of get enumerator assumes that when you're done with the enumerator, you have to dispose it. And if there's an exception that happens inside of the for each, the enumerator still needs to be disposed. So the problem with that pattern here, and especially with WebAssembly, is that finally has to go, has to be manually, has to go through JavaScript. So what happens is that the code generated here, when it comes into the try, it goes to JavaScript, wraps an inner call to this block in a try catch in JavaScript, and that is slow. That is pretty slow. So that's something that the .NET team is trying to do. And the interesting thing here is that dispose is not doing much. So they're doing something that they're calling devirtualization. So that virtual call is actually done on a list of T, and they know that the dispose of that method is doing nothing. So they pretty much just drop that block. So what we're going to try to see is how much of an impact that has. So first we're going to be validating the performance between two. So let's test a list of T and test. So we're going to be actually testing for each list of T. And we're going to try with a for of list of T. So to see the difference in performance between the two. So we're talking about a version of the runtime. So this is a version of the runtime that dates a bit, but we're going to be able to see the difference with the two. So it's going to be not for each list of T. It's going to be test for list of T. And instead of doing that way, we're going to do sut.count. And the interesting thing here is that when you're doing this, there's no get enumerator that happens behind the scene because the compiler is adding it. So you're not paying the cost of the try finally. So we've been doing that kind of optimization, removing for each to go to for loops instead of hot paths in Uno, so that it goes faster. But just so you know, but it's good to see that the .NET team is trying to improve that using fancy techniques like devirtualization. Okay, so there's that one and there's that one. So now we're going to invoke those two. So the build succeeded last time, so we're going to do it again. It should be quite fast. There's not that much that's happening in that specific area. So the linker is removing quite a bit of things. So the compiler is not doing much, or at least doesn't have to do much. So still running Python. LLD should be quite fast for this one. So you can see here that it's so there's no command line. So that one's running under WSL. And when we're going to be updating to a newer version of the runtime, you can see that it's going to be running differently. So there it is. So let's see when we're running the app. Oh, it's quite, what am I seeing here? Okay, so it's too fast. So we don't have enough, we don't have enough test points. So we're going to make an outer loop for now that does a bit more. Let's go for 5,000 for now. And let's do for elapsed first, not milliseconds. It's easier to read the other one. So same thing here. Let's do 5,000. And let's try again. What did I do? Oh, yeah. So that's not the right one. Here I don't need it. So while it's building, so we have a repository that we are using to build a custom version of the runtime, because we're enabling things that the .NET runtime is not enabling by default, namely file system access. And you know, that's the kind of things that we need and most apps need, but you know, for some reason the .NET team and Blazor team didn't think it was useful. So we're making that kind of modification so that you can use that in your applications. So each build of this is pulling versions, pulling the version, a version of the .NET runtime, and we're pushing versions to a CDN. So the release job here is pushing to a blob storage. I don't know if we can see the content here, but we're gonna have to move it here. No, it's not there. We have to be logged in to see something here. So I'm not logged into GitHub here. So I'm gonna pick it up from another window that you don't see. But if you go to upload to blob storage, you're gonna see the content right available for you. So you can take that, and we're gonna change the runtime to use a version that is updated. Okay, so now we have this one, and we can see there's a very significant difference between enumerating a list of T and a for each and a for. So you can see that it's almost a second for one and very fast for the other one below. So just to make sure I'm not enumerating things differently. So this is 1,000 for that one, 5,000 for the other, for the outer loop, and enumerating the items every time. So you can see that there's a major difference. So that explains why the .NET team wants to optimize this very badly. So now what we're going to do is actually probably could take a look at the profiler to see if we have something that is of interest there. Maybe I can show you what I meant by the back and forth between JavaScript and .NET and WebAssembly actually. So there it is. So probably was done already. Let's take a look at the profile. Okay. So lots of things, but we can see here, there's quite a few things here that are happening. And so we can see that let's say for instance, it's a test for each list of T. So that one's taking most of the time, 800 milliseconds or something. But so we have those functions, so that one and that one. So invoke III, which is invoke takes two integer parameters and returns one integer. So that's the kind of thing that you can take a look at if you are doing that kind of things. And now what we can do is go dive directly into this. And this is the actual code that's invoked every time. So when you're doing a try finally, this happens. And what is done here is that when you're entering this, there's a stack save that needs to be done so that .NET can restore its stack properly and throw properly in the WebAssembly side of things. So that jump in between .NET and JavaScript is quite expensive, and it needs to be removed pretty much. So that's why they're probably going to be having some kind of a performance improvement somehow by doing this. So we're going to be updating this. So all this is needed because WebAssembly doesn't have exception support. Once, sorry, not JavaScript. WebAssembly doesn't have exception supports. Once WebAssembly has that, that means that this block can go away, and there's no need to transition between the two worlds and just have a proper try catch that happens on the WebAssembly side. So it's going to go a lot faster. So sure, in most cases you can transform. If in your code, if you're in your code and you want to optimize and make it go faster and things like that, then you can move from a for each to a for loop. But the runtime doesn't have those kind of changes. So if you're using something that's inside of the runtime and it does a for each, then you're pretty much stuck. It's going to be using the same kind of optimization there, and it sucks. So let's do one last one. We're going to do an array just to do the comparison and see how far the kind of difference, kind of performance difference we're getting. So let's see. So instead of using a list, I'm going to be doing an array. And I'm going to be enumerating the array instead. Oh, yeah. Let's take a look at this. So that's the for each, but instead of using this one, we're going to be using an array instead. Maybe not measure the to array. Let's do a second SUT maybe. And we're going to do to array. We're going to be enumerating that one specifically. So it's going to be an array. So we're going to see if there's a difference. Oh, too fast. Test for array here. Let's terminate Clang. And let's see if we're having something interesting. Okay, so there's a question. So can you make a video about how to set up Uno and C# environment using Linux Ubuntu for Uno UI programming? That's a good idea. Yeah, we probably should be doing this and see how far we can go. We have a walkthrough on in our documentation in the get started. So it's pretty much the setup for Visual Studio Code, but you have additional steps that you can run for Linux here. For the setup, you can have to install GTK3, .NET Core 3.1 and 5, and a few additional steps there to install applications, install templates and others. So let's see the performance. Okay, so enumerating for an array, interestingly, is not that slow. It's actually the same thing as the other one. So there's probably an optimization that's being made here already. That's quite interesting. That's quite interesting. Probably it's devirtualizing already. Let's take a look at the code already to see if there's a difference there, because it's actually quite interesting. So if we take a look for array to array, that's interesting. So it's devirtualized already. There's no try finally, as you can see. So the C# compiler is already optimizing the for each enumeration for an array. That's very interesting. Okay, so that's why it's faster. So you can enumerate an array and a list of an array and a for of list of t that is approximately the same speed, but the for each is pretty slow. Okay, so now what we can do is change. We can change the Bootstrapper version of the runtime. So let's do this. So to do this, you have there's a property that you can change. It's documented at the far end. Far end of the document. I never remember where that is. I think it's at the end there. Yes, exactly. So you have overriding the .NET WebAssembly SDK build. So you can set that property in your application here, and provide a new URL for the .NET SDK. So in general, you're going to change the version of the .NET Bootstrapper here. But if you wanna do some specific changes, or if you're making your own version of the Bootstrapper, that's something that you can do. So I told you before that I had to take a look at the lists manually. So I have another window here that has the rights to look at it, and I'm going to be copy and pasting the URL here so that it overrides the contents. So this is an URL that's not behind a CDN. So if you try not to use those directly, there's an updated one that is behind a CDN, so it may go faster for you depending on where you are on the planet. So let's do it again. So now it's building, it's downloading a new version. So that version is containing the optimization from the .NET team, and we're going to see if that changes something. I hope it does, because it's something that is of significant interest for performance. Always looking for to have more performance when running WebAssembly applications. So there's probably other ways for them to do virtualization or removing that kind of stuff. I mean, that try finally semantic is something that's been there since probably the beginning of .NET. So they probably can't remove it somehow, but they can probably detect the scenarios. And to make it fast, to make it go faster. So let's see. Does it run? Does it fail? Okay, so it's a little bit faster, but not by too much. Okay, let's try it again. Yeah, it's a bit faster. Oh no, it's actually quite a lot faster. So it's probably just an optimization trick. Okay, so let's run it multiple times. Okay, so it's quite faster. So that one I can't retry manually, but we'll do it later on. Okay, so it's faster, but Okay, so let's take a look at what we have. So there's rerunning the test that does something. So let's do something like this. Let's rebuild it using the original SDK and see if that changes something. Otherwise, that means that it was just the first try that was showing the performance issue. So the thing is that when you run the application for the first time, then there's a fast compiler and slow performance that happens to compile WebAssembly to native code inside of the browser, and then they have multiple passes that optimize the code to make it run faster, but are more expensive. So if you're running it too fast, then too quickly during the application startup, then you may be missing the optimizations you have when you restart the app using F5. The application is starting again and actually going faster. So we're talking about, okay, so around 600 milliseconds. Let's do it again multiple times. Yeah, 600 milliseconds for that one. And that one was about okay, it's not too bad. It's not too bad. It's around, I'd say, twice as fast somehow. So now we can take a look at the difference between the two. So in terms of generated code. So why is it faster? So that would be the interesting part. So if we if we uncomment that one, and we're going to add one more property that is defined in the in here. So it's called profiling. So you can take this to the Wasm Shell EMCC profiling property. So what that does is that it adds more. Oh, it's actually already set. Oh, I missed it. Okay, so it adds more properties to the debugging properties to the code that's provided to the browser. So the profiler can take all those stack traces and make something that's readable. Otherwise, you're going to be seeing anonymous function something, and it's not going to be providing anything useful there. So that's interesting. That's an interesting performance improvement. So now we're going to be taking a look at what happens when profiling the application and see if we still do have a try finally that needs to be running, or if it's just still doing the try and not doing the finally. So maybe there's still the transition to JavaScript, but see, maybe there's still the transition. So we can see the difference when I run with the debugger. It's twice as slow, and when I remove the debugger and try again, I refresh, and it goes to it goes twice as fast. So just so you know, when you're doing performance, having the debugger opened or just the console opened just removes all the optimization for WebAssembly. So that's something to look out for when you're doing performance profiling, except when there's a profiler running. Okay, so I'm just doing this, and we're going to take a look at what happened during the execution of this. Okay, so we had this, and we're looking for one. You get the for each list of t, so that's the one that is taking the most time. But we want to know if, okay, so that one is actually not something that we want to see. So that's the console.write line. Looks like we're writing something to the console. Yes, we're writing. So what we want to see is the execution of the list of t. That's interesting. It's using the interpreter. That could be something of interest. So it goes faster because it's using the interpreter instead. It's still slow, but it's not. It's interesting. So it's supposed to. That's an optimization that's supposed to go away, but for some reason it's not happening. Okay, so we can't see the performance improvement there because the interpreter is doing something else. So previously you could see that the test for each was actually doing the for each, but now you can see that the for loop is transitioning to the interpreter. It's not doing AOT completely. So probably something that was changed in between versions. So that's not exactly what I was expecting. Let's take a look at one thing. So when building the application, actually we're in debug, so it could be because of this. Actually, there's nothing else happening here, but in debug there's nothing that's enabled there. So let's try it anyways. But when building for AOT, we have a file that's called build.ninja. And there are many calls to mono AOT cross. Search for cross. We have a set of optimization that are done here in EMCC. And there's one that should be called -o. It's not there. Interesting. Okay. That may explain somehow. Or maybe it's because it's a previous version of the runtime. That could be. Okay, so let's update to a newer version because we were in a previous version of 2.1. So maybe that changed in between. So let's try it again. So there's supposed to be an optimization that makes sure that even if you're using generics, it still has to go through the interpreter. It still has to go through actual AOT and not the interpreter, and that's the question here. we can see here that the execution of the test for each is actually going through and transitioning to interpreter, and it's not supposed to do that. And there's an option in the AOT compiler that prevents that from happening. So that may be, and that's something that was added in the Bootstrapper 2.1, but maybe the version that we were using here was earlier and that option is not available. So we're going to be seeing this in the build.ninja file. So maybe it's actually probably already building, so we can probably see if that's there. No, it's not there either. So maybe it's not loaded, so we'll see. So if I take a look at, forgot about that one. Okay, so we're changing the build. We have to remove the runtime as well. That's something that you shouldn't have to do manually if you're doing development here, but I'm showing you the whole step. So there's a file that's placed in that folder when the Bootstrapper starts, and if you're changing version manually using different versions of the SDK, then that file is not overridden properly, and that's the one that generates the build.ninja file. So it has to be there. So yeah, it's best to clean the temp folder and then try again. So let's see. Do I have the option that I'm expecting? No, still not there. So maybe it's something else. Well, let's see. We'll let it run to the end. Maybe there's something else that I'm missing, but probably something that we can optimize somehow. So in the Bootstrapper, there's an option that's in the packager. It's called gshared VT. So it's supposed to be here, but for some reason I'm not seeing it in the build.ninja file. So I'm probably missing something else. We'll see. Oh, I'm not looking at the right one. This is release now. Let's look at the release builds instead. Silly me. Build Ninja. There it is. Okay, gshared VT. Okay, so we have it now. So the optimization there needs to have that one. So this is controlling whether some cases go through the interpreter or actually use the optimization for shared VT. So a shared value table. So I'm not going to go into details of what that is, but it's basically when you're using generics, you get optimizations that can happen there. Okay, so let's see if we run it multiple times. Okay, 200 milliseconds. And if we go to the profiler, what do we see? So we have a time zone helper there, not particularly useful. And for each is still not doing the right thing. So it may be that there's something that has changed in the runtime, because it's not supposed to do this at all. So if we go back to the previous version, so using the stock one that was in the Bootstrapper 2.1, do we have the same performance issue? Maybe they change the heuristics to go to shared value types, and that would probably change the performance characteristics of the runtime significantly when using AOT. So we still have gshared VT here. That is the right thing. Okay. So I don't know if I still have the original one. No, I probably removed it, so I don't have the traces for the original performance profiling that I did. Okay, that's probably going to be doing it again afterwards. I'm going to or save the traces. So wasm opt, it's the last pass. Should be good to go afterwards. So for that one, so it's all interpreted, and probably not the last ones. The last ones shouldn't be. And they're running at the end. Okay, so let's see. The same thing. It's slow. It's slow in the same way. So it could be that the scenario that I was expecting is not there at all. Okay, so it looks like it's something that changed somehow in between, because it was available originally, but it's not anymore. So actually ran the application twice, but that's not a problem. Okay, so there's the at range. Oh, for each list of t. Okay, that one is. Okay, so that one is actually not using. Okay, so it does work. Okay, so it's not faster, but it does work. Okay, so you can see here that now that the for each list of t is really using AOT, so it's not using the interpreter. So that does work. So that's the good part. So that means that the OG shared VT is doing something. Now, is it going faster? That's to be seen. So if we do the update here, so I'm gonna refresh. So I'm refreshing here. So it's 400 milliseconds. Yeah, 400 milliseconds. So we're using a recent version of the runtime, but not using the latest version of the runtime. So recent 2.1. So if we go to the latest version of the runtime, then we're losing the optimization for the enumeration of the for each. So it looks like it's doing nothing. So the optimization that the .NET team made, for some reason, is not doing anything useful, because the list of t here is going through the interpreter and not going through AOT. So that's a problem. So just to confirm, I'm building it again using the latest version of the runtime, and that I do have the option in the build.ninja that does shared value type, which is the right one, but I'm not getting anything interesting with regards to enumeration. So maybe they did change something in between, or maybe it was done after or something like that. So we're going to be having to discuss that with the .NET team to understand what's going on, because it's not good enough. Okay, so that would be the last test for the day. I hope you're learning a bunch. You know, it's always interesting to go into the weeds of the .NET runtime and see how that works, and your performance characteristics and things like that. It's always a bumpy ride, because you're on the bleeding edge of stuff, determining what the .NET runtime is going to be doing and why it's doing it, and specific optimization for using generics and combination of all those things. So what we can say here is that the optimization that was made is not particularly useful for some reason. And if you're wondering what those numbers are, the middle one is the base commit that was used to build the .NET runtime version of Uno. So if you go to .NET runtime and you go to that specific commit here, you're going to find which one was used to do that. So this one's using enable the virtualization for more scenarios, not particularly useful. But I think there was one about optimization that was done. So it dates back a bit, 5 days ago. So I thought the optimization that was made by Zoltan was there, but maybe it's not. Maybe I missed it. So we're going to try to find that one out later on. But so I had the update there. So 300 milliseconds and so 200 milliseconds. And we're running here. Sorry. We do performance profiling. It's likely that we're still running in the interpreter instead of running this time zone helper, not particularly useful for that one. Yes, okay, so it's running there. So there's a regression somehow there where shared value tables are not generating AOT instead of the rest, even though the option's there. So, well, okay, so some more discussions to make with the .NET team. So this was a fun one. Thanks for attending, and if you're watching this using the recordings, let me know what you think, and stop by next week if you can. Until then, have fun.